Before the arches, before the baths, ancient Rome was a city dying of thirst, choked by its own rapid growth.
By the 4th century BC, local sources were polluted, spreading sickness and limiting the future of ancient Rome.
The only answer lay in bringing pure mountain spring water from miles away to the heart of ancient Rome.
The solution was the Aqua Appia, ancient Rome's first aqueduct, which ran almost entirely underground.
The secret was gravity. Ancient Roman engineers had to calculate a precise downhill slope.
The Roman surveyors, or libratores, used instruments like the chorobates to achieve unbelievable accuracy.
They created an artificial river, protected from the scorching sun and invaders within sealed channels in ancient Rome. This continuous, moving water required constant maintenance and brilliant, complex planning throughout ancient Rome's territory.
The immense manpower required was organized with military precision, reflecting the discipline of ancient Rome.
The stonecutters, the laborers, the builders, hundreds of thousands of people contributed to the Aqua Claudia alone in ancient Rome.
The aqueduct arches were only used when the channel had to cross deep valleys or remain elevated on the flat plains.
The secret to their strength was the Roman arch. It transfers the enormous weight down and out, making it stable across massive spans.
Think of the Pont du Gard, a masterpiece built without mortar, each stone precisely cut to fit perfectly, enduring centuries in ancient Rome. Builders constructed massive wooden scaffolding, or centering, to support the stone arches until the final keystone was set.
The construction was often dusty, dirty, and perilous, demanding incredible coordination from the builders.
To cross very deep ravines, the aqueducts sometimes used a reverse siphon, utilizing pressure to push the water across the valley floor.
The channel itself was lined with a pink waterproof cement, called opus signinum, to prevent leaks and keep the flow pristine.
Sediment would build up, so the Romans designed settling tanks, piscinae limariae, at regular intervals to filter the water before it reached ancient Rome.
Look at the scale. These structures were powerful symbols of imperial authority, stretching from the emperor's palace across ancient Rome. The very sight of the aqueduct arches reminded every citizen of the power and organizational genius of the emperors of ancient Rome.
Upon reaching the city, the water flowed into a massive distribution tank before being divided.
The ultimate goal was flow, delivering an estimated 1 billion liters of clean water to ancient Rome every single day. Maintenance was constant. Crews were tasked with removing thick calcium deposits, incrustation, to maintain flow.
They had to use extremely precise tools to create the perfect curves and surfaces required for the internal channel.
The luxury of the frigidarium, the tepidarium, and the caldarium defined social life.
Clean water powered thousands of public fountains, providing free, essential access to every citizen of ancient Rome, rich or poor.
The noise of running water was a constant, soothing soundtrack to daily life, a luxury unheard of in other cities.
Wealthy private homes could pay a fee for a pipe directly into their house, often regulated by a bronze flow meter.
Water was also crucial for public hygiene, constantly flushing waste out of the public latrines and into the vast Cloaca Maxima sewer.
The water pressure even powered mills and complex fountains, demonstrating ingenuity that was millennia ahead of its time.
Every drop, every arch, every pipe, it all solidified Rome's status as the most advanced city the world had ever known.
Roman lead pipes, often stamped with the emperor's seal, ensured precise flow and documented ownership. The aqueducts were built in layers, rough stone below, and finely cut ashlar masonry for the upper arches. The shadow of the massive arches tracked the sun across the plains outside ancient Rome, a colossal, functional sundial of stone. To prevent siphoning and theft, unauthorized tapping of the aqueducts was punishable by heavy fines, or worse. The stone piers were often hollowed out to save material, but the outer shell was reinforced with durable Roman concrete. The sheer manpower required for construction often meant working in sweltering heat, demanding immense physical endurance from the workers.
Engineers had to carefully map underground geological faults to ensure the longevity of the numerous tunnels.
The public fountains often featured artistic bronze or marble masks that the water flowed out.
The sound of the water flowing could be heard through vent shafts built along the channel's path.
The aqueducts were not just functional, they were often highly decorative, incorporating temples and monumental gates.
The primary construction material was volcanic ash concrete, stronger and longer lasting than any other known in ancient Rome.
The spectacle of water was an art form. Public works included enormous, theatrical fountains called nymphaea.
Water was measured using a unit called the quinaria, which regulated the flow for both public and private consumption.
The system was highly pressurized, forcing engineers to utilize strong bronze valves and taps to control the flow.
The massive project required centralized organization, the job of the curator aquarum, an appointed official in ancient Rome.
The arches often carried 2 water channels stacked vertically, doubling the capacity on a single structure.
To build the long, dark tunnels, workers used oil lamps and chisels, proceeding by trial and error through solid rock.
The aqueducts were so reliable that citizens could forget the desperation of the polluted Tiber, elevating the quality of life.
The public latrines often became social meeting places, another unexpected benefit of the clean water infrastructure. The construction camps themselves were small, temporary cities, requiring their own supplies and logistics far from ancient Rome.
Roman engineers invented specialized tools, including the water-leveling dioptra, for surveying difficult terrain. The midday sun beating down on the white stone of a newly completed pier. Close-up on the wheels of a Roman supply cart, heavily loaded with tools and cement bags.
A small bird lands on the edge of the smooth, running water channel inside the specus.
The shadow of a massive, unseen arch slowly covers the ground below.
A Roman coin, an as, being used to pay a construction worker's wages. The sound of the stone chisel on hard rock, echoing inside a narrow tunnel.
A group of Roman school children or a field trip, pointing up at the monumental arches.
Close-up on the brass key used to lock a water gate, or vane, inside a control chamber in ancient Rome.
The turbulent, foamy water inside a castellum distribution chamber, where the flow is highly agitated.
A shot looking straight up the side of a massive aqueduct pier, emphasizing the vertical climb.
The smooth, wet surface of the opus signum channel, reflecting the light from an access hatch. A Roman sentry guard walking his patrol along the top of the aqueduct arches outside ancient Rome.
A farmer's irrigation ditch, taking a controlled overflow from a small spillway on the aqueduct.
The warm steam rising from the caldarium, hot room of the public baths.
A group of architects discussing a detailed wooden model of a proposed aqueduct line.
The moment a worker removes the wooden centering and the newly built arch stands on its own for the first time.
But this complexity was also a vulnerability. The aqueducts were often a strategic target for invaders threatening.
Cutting the water supply was a simple, devastating way to besiege the vast city. As the empire fragmented, the central maintenance required to sustain the distant channels in ancient Rome disappeared.
Without imperial funding, the citizens returned to drawing water from local wells and the polluted Tiber, just as before.
The great baths emptied, the fountains ran dry. The soothing sound of running water in ancient Rome was replaced by silence. For centuries, the massive stone ruins stood in the countryside, monuments to a lost age of grandeur and power. Yet, the foundation of the Roman system survived, influencing hydraulic engineering well into the modern age.
The Roman methods for tunneling and surveying are still referenced by engineers today, a true gift from ancient Rome.
The aqueducts are more than stone. They are in the rise and fall